In this video, I have a subnetting problem where I need to find the valid host range, the range in which I can set up IP addresses on computers. And I have an IP address that's within that range, and I have my CIDR notation subnet mask. So I need to find out the first valid host to the last valid host in order to define the valid host range. So the first thing I want to do is I want to convert my subnet mask to binary. And to do that, I'm going to use my /27. It tells me that there's 27 ones in my subnet mask. The first 27 digits are a 1. So there's 24, 25, 26, 27, and then the last 5 are zeros. The next thing I need to do is I need to convert my IP address into binary. But something that I can notice is that the first 3 octets in this case are all 1s, so I don't even need to change those. I know that 172.24.248 is going to encompass the entire network that I'm working with. It's just that last octet that I need to worry about a little bit. So my answer is going to be 172.24.248 dot something through something. Some range I'm looking for here. So all I really need to do as far as converting this IP address is I only need to convert that last octet. It saves me some work. So I'm going to turn 47 into binary, and I'm going to write it right down here below my last octet. 128 doesn't fit, 64 doesn't fit, 32 does fit. So from 47 I can take 32 and I'm left with 15. 16 doesn't fit, but I know 15 is everything else. Because if 16 didn't fit, 1 less than 16 is my answer. So anyway, this is my 47 in binary. I'm going to draw a line between my 1s and my 0s in my subnet mask. And the reason I do this is to define the network side and the host side. Something I know about IP addresses is the network side doesn't change from the very first host to the very last host on a network. It never changes. It's always going to remain the same. So what I like to do is I draw this N1LB chart here, N1LB, and this represents the network ID, the first usable host, the last usable host, and the broadcast. And in this case, I need the first usable host and the last usable host to identify my range. If I'm looking for a range, it's got to be the first to the last. The network side never changes. That's why it's all part of the same network. So I can carry this down. It's never going to change. The network ID and the broadcast have the same digits in the network side. Now, it's this host section that gets a little garbled up. So the network ID in the host portion is always the smallest possible number. Think of these like bookends. This is the very beginning of the network, and this is where it starts. This all defines the network over here, but this defines all of the hosts in that network, from the very smallest, which is all zeros, to the very largest, which is all ones. If I wanted the network ID, there it is in binary. If I wanted the broadcast, there it is in binary. But actually, the 2 pieces I need are the pieces that aren't there yet. So you can logically understand that in order to display the first and the last, it's going to be something a little bit bigger than the network ID and something a little bit smaller than the broadcast ID. So what's the smallest number I can make that isn't already represented here as the network ID, which is zeros? The answer would be 1. And then what's the biggest number I can make that isn't already used by this broadcast. It's going to be 11110. So now what I need to do is I need to take this first usable host and this last usable host, and I need to convert them back into decimal so that I can use them for my answer. So 128, 64, 32. I know I've got a 32 there. And I also need to add in this 1, 33. The first usable host on my network is 33. And then this one's a little bit more complex. I'm going to add in the 32, the 16, the 8, the 4, and the 2. 128, 64, 32, 16, 8, 4, 2, and 1 are the values for each of those bits. So I've got 5 of those middle bits there. So I want to add this up, and I'm going to gather up my 2 that equal 10, and these 2 equal 10. So I've got a 2 left. 1, 2, 3, 4, 5, 6, 62. Just to kind of fact check my work here, the network ID is always even. The first usable is always an odd number. The last usable is always even, and the broadcast is always odd. Now you can see that in this last digit here as well, zeros are even and ones are odd. But it's just a nice little way to check to make sure I have an odd number through an even number in order to demonstrate that range. So my answer for my valid host range for the network that this address is a part of is 172.24.248.33 through 62. And one more last check that I need to make sure fits. The 47 is within this range. So it looks like that answer is correct.